All right, so lesson 7, we're going to do scale drawings and models. That's what we're working on today. So the two things we'll do, the first one will be to actually interpret scale models. So you will have a scale model that will be in the book. You'll be using a ruler to measure it, and then being able to kind of compare the actual distances on that scale model. And the other one we're going to do is going to be scale factors, where you're just going to be getting kind of some numbers, cross multiply, and you'll be able to figure that stuff out. So when we look at the ruler that you have in front of you, first thing I'm going to do is I'm going to start off with just the ruler. Okay, and I'm going to slide over here just for the ruler portion. Okay, for the ruler portion, again, I'm going to give two different parts. The first one is going to be the metric part. So on your ruler itself, you'll see the marks for centimeters. You're going to have the big number here. That's where like the 0 or the 1 or the 2 or whatever is going to start off with. And then over here, you'll have the next number. So the 1, the 2, however it goes. The nice thing is when we're dealing with metrics, with the metric side, everything is broken up into tens. So every single notch you use is going to be 0.1. So the middle part here, so you'll see that it does have this one extra longer notch. That's going to be at 0.5 or 5 millimeters. So I'll kind of put it as a 0.5 right there. Otherwise, every single notch that's on there is giving you 1/10 of a centimeter, or you can say 1 millimeter. Okay. The reason I'm saying this is when we start looking at the scale models themselves, they're going to ask you to measure either using the metric side or the inches side. And I've learned a while ago that when I make the assumptions that you guys have it, sometimes I'm going to be off. So I just want to make sure I go over this perfectly. So again, the really tall lines are going to tell you the full centimeter, the metric part, with every single individual one being 1 millimeter. And there's 10 in between it. When you do scale models with metric, you can use decimals. Okay, the metric one is probably the easiest one to do with scale models. However, when we get to inches, okay, inches will be on the other side. It's kind of harder to see. They don't make the lines nearly as big. But they do have a couple longer lines. I'm going to start off. Here's my 0. Here's my 1 inch. In the middle, there is one that's a little bit bigger. Okay, in the center, and with the kind of the customary, the inches side, we're going to have to use fractions for pretty much everything. It's not going to be as easy to make decimals as the metric side is. In between the half inches, there's also kind of one more. It's barely taller, but it is there. That'll be your 1/4 inch. Whoops. So that'll be 1/4 right there. On this side, it'll be 3/4. So if you wanted to write it as 0.25, 0.75, that's fine. But again, they're there. They're just really hard to see. Okay, past that on this ruler, you really can't tell too much. But they are able to break down in between each one of those into the eighths. So this would be like 1/8. This one here would be 3/8. This would be 5/8. And this is going to be 7/8. And then finally, on the ruler that you have here, it does give you a little note that says each line is 1/16 of an inch. So if you use the next line that's on this ruler that you have here, okay, that's going to be 1/16, or you've got 3/16, or you've got 5/16, 7/16, 9/16, 11/16, 13/16, and then 15/16. If you start getting into the decimals for these ones and you're wanting to write down a decimal for 16, I'm going to tell you what the number is, but this is why I'm encouraging you to use the fractions themselves. If you wanted to write down the decimal, every 16th of an inch is the same as saying 0.0625. You're going to get some really, really small numbers and a lot of decimals that you'll have to work with. So, if at all possible, I would say use the metric system, centimeters, millimeters. I'm letting you know in your assignment today you don't have to use the customary, but I want you to be to understand what those measurements actually mean. Okay, so when we're dealing with scale models, you will need to understand how to get to these numbers on the ruler itself. Questions on the ruler? Awesome. So that's pretty much objective number one, because I really can't measure some things very well on the big board. All right, so for this section, we're going to be dealing with scale models. A scale model is a scale drawing or an object that's actually going to be drawn to the proportional lengths to the actual object. Okay, as a kid, did anybody have like Matchbox cars?
Oh, what'd you say?
Like, as a kid, did you ever have Matchbox cars, like the little tiny cars? Those usually like 1/25 the size of an actual car. Meaning if you were to multiply everything by like 25, that would be the actual size of a car. I don't know about you guys, but I know like at my grandparents' house, they had like a bunch of like scale tractors, like little metal tractors. Those are like 1/25 the size, or 1/40 the size. Again, those scale models are going to represent the actual size of the thing, but it's going to be able to be drawn at a smaller method. Okay. The other thing that people use, they don't use nearly as much anymore, but you'll still see it, are going to be maps. Okay. Maps are going to be drawn on a sheet of paper about this size, actually a little bigger than that. But that way you can actually carry it around. There's no way you can have like a 1-to-1 map where you have a map that's the exact same size as the state of Iowa. It's a lot of paper. So that's what we're going to be using these scale models for. Excuse me. So it says the distance between Boston and Chicago, sorry, on a map is 9 inches. And it says the scale of the map is 1 inch is 95 miles. What's the actual distance? So the way we set these up, just like kind of the way we've been setting up all the other proportions, I'm going to give it a label. I know on the top, I'm going to say is my map, scale, and then on the bottom, I'm going to put the actual distance. So that's kind of the way I'm going to set it up. So it says between Boston and Chicago is 9 inches. And then it says my map scale is 1 inch is the same as 95 miles. So I want to figure out how far the actual distance between Boston and Chicago is. As soon as you figure out how you're going to set it up, it turns into just another one of those cross multiplication. Okay, so I get to go through, cross multiply, And then it turns into 9 times 95. We're going to get 855 equals the x. Now, the one extra step that I want to make sure that you're aware of. What label did I have for the map up here? Inches. Okay, so this one was inches on top. Is my label. On the bottom, I have miles. So when I get done with this, I see that the x was on the bottom. I know that the label that's going to go with this number needs to be miles. So the distance between Chicago and Boston is going to be 855 miles. Okay, just make sure you kind of set it up with the same labels. So like this one, I was going to do the map over the actual. When they give you a scale factor in a map, it is pretty much always going to be the map scale over the actual distance. And realistic, I think I'm going to do about 3 examples total, and you guys are good to work. Anybody need more time? Okay. So I'm going to go on to example number 2. You guys will talk me through this one. Let me get a different color too. You guys will talk me through this one. The distance between Nashville and Chattanooga is 1 inch on a map. The scale of the map is 0.4 inches to 40 miles. What is the actual distance from Chattanooga or Nashville to Chattanooga? So talk me through, how am I going to set this thing up?
40.
Okay, so you're going to do the 0.4. So I have the map over the actual. So I had 0.4 over 40. And I'm just going to put the, inches, and I'm going to put miles here just so I have the labels.
Do 1 over x.
Perfect. And it said the distance between them was 1 inch. So that'll be on the top because it has the label of inches. And I don't know how far the actual distance is. So again, these all will have the label of inches. These will all have the labels of miles. My scale factor, 0.4 over 40, goes here. My map, the actual, is going to go there. Cross multiply, which gives me 0.4 x equals 40. Divide both of those by 0.4. I get x equals, make sure I don't screw it up, 100 miles. Again, the 2 ways you can kind of make sure to know you're doing it right. If you put the map over the actual, or if you put your label over the other label. Okay? So far, so good? Okay, so this next one, it gives us the same thing. It says a miniature replica of a jet fighter is 4 inches long. The actual length of the jet is 12.8 yards. Okay, I need to go through and I need to figure out what my scale of the model is going to be. It is all the exact same thing, so I don't need to do cross multiplication. I just get to work with those numbers by themselves. Okay, for me, I'm going to go through and I'm just going to write my labels down so that way I don't mix anything up. So I've got inches on the top. I've got yards on the bottom. Usually you want to have the smaller measure on the top, the bigger one on the bottom. So my scale factor is going to be 4, or my scale itself will be 4 inches over 12.8 yards. When we are dealing with the scale, we want to make sure that the number we use, because it makes it a lot easier, is going to be a 1. If we can compare everything to 1 inch, we can figure that out. So if I wanted to change the top to 1 inch, I can set it up as cross multiplication. I could set it up as 4 over 12.8 equals 1 over x, and I can do it that way. And cross multiply and figure it out. Otherwise, I think some of you guys kind of caught it right away. What else could I do without having to set cross multiplication up? So I'll do it this way, and I'm going to show you the next shortcut trick. Okay, I'll do cross multiplication. I got, let me slide over. 4x equals 12.8. Divide this by 4, divide this by 4. I get x equals 3.2. So my scale factor for that one is going to be, I'll put it right up here, 1 over 3.2. So 1 inch is 3.2 yards. The shortcut that I could have done, I knew I want my top number to be a 1. I can just divide this one by itself and then divide the bottom by the exact same number. So 4 divided by 4 is 1. 12.8 divided by 4 is going to give me this one. It's the same thing we did in cross multiplication. Just trying to show you one little shortcut. If you like doing the cross multiplication, stick with it. It will give you the exact same answer. But I just want to kind of show you that little shortcut if you'd like to do it. Okay? Questions in that part? Okay, so this last part is going to take what we did from last chapter, a couple chapters ago. It says how many times as long as the model is the actual jet. So for me to do this last part, I'm going to get the scale up here. My scale was 1 inch over 3.2 yards. In order for me to figure out how many times it is, they need to be the exact same label. So this one's in inches, this one's in yards. What I need to do is I need to convert those 3.2 yards into inches. Thoughts on how I can do it? All right, I will draw it out for you then. Hopefully this kind of jogs your memory. This is the one where we can kind of go through and do this thing. My bottom label I want to be in inches. So I've got yards up here. I can change yards to feet. So in 1 yard, there's 3 feet. Those labels cancel out. And then I can change feet to inches. In 1 foot, there's 12 inches. These labels cancel out. Now I can multiply straight across. I've got 1 over 3.2 times 3 times 12. One 115.2.
Isn't there just a sheet we can use? Like, didn't we get a sheet that had like?
Yeah, and it had these exact same. They didn't have one that jumped all the way from there to there. But yes, I still can get some more sheets if you want it. But yeah, all you're doing is you're just going to convert to make sure they have the exact same labels. So those feet or those yards are going to turn into inches. So once I compared the two of them, the model is going to be 115.2 times as big as the model itself. Thumbs up, thumbs down. Okay, this should be my last example then. Okay. Mrs. Alejandro's history class made a scale model of the Alamo that's 3 feet tall. The actual height of the building is 33 feet 6 inches. What's the scale model? I want you to try to get the scale model right now. So you just make sure it says 2 inches. Otherwise, you won't put a decimal. We want to change this top one to be a 1. So it would be 11 feet 2 inches. That decimal is going to throw it kind of off. If you go that way, but yes, 11 feet 2 inches. So you're going to change it to a decimal because you 32.5.
Oh, yeah.
Yep. Otherwise, you can use feet and inches together if you want. Either way, so what we're saying. I need to know some inches too. Inches are a decimal. It's not just 11. It's more than just that. What? Yes. I think we're going to find 2, but. To be 3 over 33, I just put 33 over that 33 and divided 3 by 1 feet or 3 that's 3 feet 6 inches. We wouldn't worry about the decimal. Yeah. Here, I'm going to show both ways. Okay, tell you what, some of you guys are kind of getting thrown off with the feet and the inches, so I'm going to show you both ways that you can solve this one. Okay? Because a lot of you guys are like right there, but it's kind of getting a little goofy. So I can say that it's going to be 3 feet over 33 feet 6 inches. If I do it this way, I'm going to divide everything by 3. So I'll zoom in just a little bit, which would give me, I'm going to show it 2 separate ways. I'm going to take 33 feet divided by 3, and I'm going to do those 6 inches divided by 3, which gives me 1 over 11 feet 2 inches. Okay, so if you did 11 feet 2 inches, because you're taking the feet divided by 3, the inches divided by 3. However, if you want to work with it in decimals, and I'm good with decimals as well, before you can get to doing this part here, we need to change that 33 feet 6 inches into a decimal. So it'd be 3 feet over 33.5, because 6 inches is half of a foot. Okay? So I take 3 over 33.5. At that point, I can go through and I can get my decimal here. 33.5 is going to be 5 divided by 3. I'm going to get 1 over 11.16 repeating. Okay? So I'm good with this is my answer. I'm also good with that for the answer. Okay, now the part that I'm going to look at, this label on the top was feet. The bottom label was feet. For part B, it says how many times as tall is the model as the actual building. I don't need to convert anything anymore because they both have the exact same label. Okay, they both have the exact same label. It's asking me how tall is the model, or how many times as tall is the model, or as the model is the actual building. So the actual building is going to be 11.16 times as tall. If you were using this one here, you need to change that 2 into a decimal. So it would be 11 plus 2 divided by 12, which is 11.16 repeating. Yes, sir.
Do we actually need these?
Yes.
Okay.
Yep, you will actually use it for the part of the test. Questions on this? How you guys feeling? Okay, I'm not going to go over the extra examples then. Your homework, 520, 5 through 8 all, 16, 17, 18, and 19. These first 4, you will use the actual ruler. Okay, the first 4, you will use the actual ruler. For the last 4, you're just going to be doing the comparisons with the scale models.